First, a quick lesson in engine valves and what they do. On this big old cutaway Ford Shelby motor, you can see them clearly. The intake valves open to let the air and gas into the cylinder. The exhaust valves open later to let the burned air and gas out of the cylinder, down into the exhaust. Valves are operated by camshafts. You see these guys up here, they turn with the engine, and these off-center lobes that are mounted on them push the valves open or not as they turn around. These are dual overhead cams. There's one cam for exhaust valves, a separate one for intake valves. Also notice this engine has 4 valves per cylinder, like many do these days, if you've got more area to let the engine breathe in and out. But here's the problem. A strictly mechanical system operates the same way at all RPMs and all engine loads. That's not ideal for MPG, horsepower, or emissions. You want to vary this behavior at different points of the engine's rev range. That's why we have variable valve timing. And it changes 3 parameters.
Valve timing. At what points in the engine's rotation do the valves open and close? Valve duration. How long the valve stays open once it is. And valve lift. How far a valve moves off its seat when it opens.
So varying all those valve events, as they're called, allows this engine, and most importantly, its electronic control unit, can constantly make a call to get the most power, the best MPG, and the lowest emissions all at once. Now, I could do an hour on why that works, but here are just a couple simple examples. If you leave this exhaust valve open longer on one stroke, you get all the exhaust blown out of there. That leaves a fully open and clean cylinder to take in the maximum gas and air on the next gulp, and that could give you more power. On the other hand, if you close that exhaust valve a little sooner, you leave some exhaust in here. That fills part of the cylinder, and therefore you take in less air and fuel the next time. That kind of creates a virtually smaller engine for a moment. That could give you better MPG. Now, the mechanisms that allow these valves to change their behavior are almost as numerous as there are manufacturers of engines. Here are just a few examples. First of all, some cars have multiple sets of lobes on their camshafts, and different lobes of different shapes are used at different points in the engine's operation. Here's another example. Sometimes you will change the relationship between the rotation of the crank and the rotation of the camshaft, so they aren't always locked 1-to-1. Another technology is what's called an eccentric cam drive. So the engine's turning at a certain RPM, but eccentric drives here on the ends of the cams allow them to accelerate and decelerate their rotation. That gives you a degree of control as well. Now, who invented all this variable valve timing stuff? Interestingly, Fiat is often given credit as having the first mainstream production-ready system, dating back to a 1969 patent application. But today, you know it as multi-air. We saw it recently in the new Jeep Cherokee, now owned by Fiat, of course. It's their version of changing valve events using hydraulic pressure out of the oil system. The most famous kind of valve timing, yes, valve timing can be famous, is Honda's VTEC, the source of one of the biggest memes ever on the internet. And just about every car maker has their own brand of variable valve timing, and they push it hard, which is weird considering how few car buyers have any idea what it is. But now at least you've got a pretty good idea of how this one technology has dramatically improved how engines raise MPG, increase horsepower, and lower emissions. It's one of the great revolutions in engineering in cars in the last few decades.